Water is the lifeblood of our planet. It's a resource that sustains all living things, yet few of us fully understand the complex process that keeps it in constant motion. In this video, we will explore the water cycle, also known as the hydrological cycle, and discuss how this continuous movement of water through Earth's atmosphere, land, and oceans supports life and shapes the planet's ecosystems. The water cycle is a process that continuously circulates water, ensuring that it moves between the Earth's surface and the atmosphere, driven primarily by the energy from the sun. Without this cycle, the world would face droughts, flooding, and ecosystems that could not survive. In this video, we'll break down each stage of the water cycle: evaporation, condensation, precipitation, and infiltration, and discuss their significance to life on Earth. Let's start with the first and most critical stage of the water cycle: evaporation. Evaporation occurs when the sun heats up water bodies, such as oceans, rivers, and lakes, causing water molecules to gain enough energy to change from liquid to gas. This water vapor rises into the atmosphere and begins its journey around the planet. This stage doesn't just happen in water bodies. Transpiration is another form of evaporation, where plants release water vapor into the atmosphere through their leaves. Together, these processes are responsible for moving large quantities of water into the sky. But what happens to that water vapor once it's in the air? The next stage is condensation, which occurs when the water vapor cools down and turns back into liquid water. This process forms tiny droplets, which collect and clump together, eventually forming clouds. Clouds can vary in shape and size based on factors like temperature, humidity, and the amount of water vapor in the air. Some clouds are fluffy and light, while others can become thick and heavy, ready to produce rain, snow, or hail. The role of clouds is critical in the water cycle because they store and transport water, releasing it back to the surface as precipitation. Next, we move to precipitation, the stage where the condensed water droplets in the clouds become heavy enough to fall back to Earth. Precipitation can take several forms, such as rain, snow, hail, or sleet, depending on the temperature of the air and the cloud. The water that falls as precipitation plays an essential role in replenishing rivers, lakes, and underground water reserves. Without precipitation, land would become dry, ecosystems would collapse, and plants and animals would struggle to survive. After precipitation, the water doesn't just stay in one place. It moves through the landscape in various ways. Some of it will infiltrate the soil, meaning it will be absorbed by the ground and replenish groundwater. Groundwater is stored in underground reservoirs known as aquifers, which provide drinking water for millions of people worldwide. Infiltration is especially important because it ensures that the water supply doesn't only rely on surface water, but is replenished below ground as well. However, not all precipitation is absorbed into the ground. Some of it will flow over the surface, especially in urban areas or places where the land is too hard or compact for the water to penetrate. This is called runoff, which moves water from higher elevations to lower ones, eventually reaching rivers, lakes, and oceans. Runoff helps maintain the flow of freshwater sources, which are vital for drinking, agriculture, and supporting ecosystems. During periods of heavy rainfall, too much runoff can lead to flooding, which can cause significant environmental damage, but it also plays a crucial role in distributing water across regions. The entire water cycle is powered by two fundamental forces: solar energy and gravity. The sun's heat drives the process of evaporation, while gravity causes precipitation to fall and moves water across the landscape through runoff and infiltration. This continuous movement of water helps ensure that the planet's water supply remains balanced, recycling and redistributing water around the world. One remarkable aspect of the water cycle is that the total amount of water on Earth remains relatively constant. Water does not disappear, it simply moves from one part of the cycle to another. The water that falls as rain today may have been part of a cloud millions of years ago, or it could be the same water that passed through your body. This constant recycling ensures that the Earth has enough water to sustain life, although the distribution of this water is uneven. Some regions receive abundant rainfall, while others are drier, and some areas may experience droughts or floods due to natural variations in the cycle. Human activity, however, can significantly impact the water cycle. Activities such as deforestation, urbanization, and agriculture can disrupt the natural flow of water. Deforestation reduces the amount of transpiration, which can alter precipitation patterns and lead to drier conditions. Urbanization, with its concrete surfaces and impervious roads, limits the ability of water to infiltrate the soil, leading to more runoff and greater risks of flooding. Pollution from factories and agricultural runoff can contaminate water sources, making them unsafe for consumption or agriculture. In some parts of the world, over-extraction of groundwater has led to the depletion of aquifers, which could take thousands of years to replenish. The impact of climate change is also affecting the water cycle. Rising global temperatures are increasing the rate of evaporation and changing precipitation patterns, leading to more intense storms, prolonged droughts, and shifting water availability across the planet. In some areas, rainfall is becoming more erratic, leading to water shortages, while in other areas, heavy rain is causing severe flooding. Understanding the water cycle and its complexities is crucial for managing water resources effectively, especially as the global population grows and the effects of climate change become more pronounced. By learning how water moves through the cycle, we can better protect our water sources, reduce waste, and promote sustainable practices in agriculture, industry, and urban development. Efforts to protect and conserve water include everything from rainwater harvesting, which captures precipitation for later use, to water-efficient farming practices, which reduce the amount of water needed to grow crops. Water treatment plants play an essential role in ensuring that water remains safe for human consumption and in preventing contamination from industrial pollutants. One of the most exciting developments in understanding and harnessing the water cycle is the technology of desalination. This process involves removing salt from seawater to make it drinkable, which could become a game-changer in providing fresh water to regions suffering from water scarcity. Another promising technology is cloud seeding, a form of weather modification used to enhance precipitation, especially in dry regions. In conclusion, the water cycle is one of the most vital natural processes on Earth. It drives the movement of water through our ecosystems, supports life, and regulates the Earth's climate. From evaporation and condensation to precipitation and infiltration, the water cycle's stages play an essential role in ensuring that water remains available for all living organisms. As we face challenges like climate change, water scarcity, and pollution, understanding and protecting the water cycle has never been more important.